Hello, this is part 2 of the logarithms topic, and today I'm going to be proving the laws of logarithms, as well as other fundamental principles of logarithms. So let's have a look at the first law of logarithms. Consider x equals a to the b and y equals a to the c. Hopefully by now you should know how to express this as a logarithm. So we say that log base a of x equals b and log base a of y equals c. Let's say we want to find the product of x and y. So you can say that xy is a to the b times by a to the c. And we know from the laws of indices that we can write this as a to the b plus c. Let's express xy equals a to the b plus c as a logarithm. So we'll have log base a of xy equals b plus c. But we know what b is, and we know what c is. So let's substitute these in to have log base a of x plus log base a of y equals log base a of xy. So this is our first law of logarithms. So if we wanted to multiply two numbers together and express that as a logarithm, all we need to do is just add together the logarithms of the two numbers, so x and y in this case. Let's have a look at the second law of logarithms. So suppose we have x equals a to the b and y equals a to the c again, and let's do the same thing and express this as a logarithm. So we have log base a of x equals b and log base a of y equals c. Now, let's consider the ratio of x and y. In other words, x over y. So this is equal to a to the b divided by a to the c. And again, from our laws of indices, we know that this is equal to a to the power of b minus c. And again, as we did in the previous law, let's express this as a logarithm. So we'll have log base a of x over y equals b minus c. But we know what b and c is, so let's substitute that in, and we'll get log base a of x minus log base a of y is equal to log base a x over y. And this is our second law. Let's look at the final law of logarithms. This is known as the power law. Let's consider x equals a to the b once again, and we know that we can write this as log base a of x is equal to b. Let's say we rose both the left hand side and the right hand side to the power of c. So this will be x to the c is equal to a to the b raised to the power of c, which we can write as a to the bc. Think of x to the c as a single term. So you can write log base a of x to the c is equal to bc. And we know that b is log base a of x. So let's rewrite that. To get log base a of x multiplied by c. And if we just rewrite this in a nicer way, we'll get log base a of x to the c is equal to c times by log base a of x. And this is our final law of logarithm. So whenever we need to find the logarithm of a power of a number, we can say that this is equal to multiplying the logarithm of that number by that power. What if we wanted to find out the value of log base 2 of 9 plus log base 7 of 81? Because 9 isn't a power of 2 and 81 isn't a power of 7, we don't know the exact values, so we can't add this very easily. So now you may be thinking that we can use our multiplication law, in other words, our first law that we proved earlier on in this video. But we actually can't do this because the multiplication law of logarithms only works for the same base. And here we have log base 2 and log base 7, so we can't use that here. There is a principle in logarithms that we can use to find out this result, and this is called changing the base. So what does this actually mean? Well, we're going to change the bases so that each of our logarithms has the same base, so it'll be easier to add. Then we could just use our multiplication law, and we'd get the answer straight away. So let's prove the changing the base principle. Let's begin by saying that b to the x is equal to a to the y. Let's solve for b. So we can raise b to the power of x times by 1 over x, so that we can cancel out our x's. And obviously we'd have to do the same thing on the right hand side. So y times by 1 over x. You can see here our x's cancel to give us b to the 1, which we can write as b equals a to the y over x. Now let's take log base a of both sides. So here we can get log base a of b is equal to log base a of a to the y over x. We are allowed to do this because it's just the same as multiplying both sides by 5. So we can take log base a of both sides, and that's fine. We can do that. So now, using the power law of logarithms, we can bring this power down. So here we'd get log base a of b is equal to y over x times by log base a of a. And from our previous video, we saw that log base a of a is actually equal to 1 because they're the same base and number. So let's simplify this so that we get log base a of b is equal to y over x. We know from the beginning that b to the x is equal to a to the y. So let's redefine this and say that z is equal to b to the x, and therefore z also has to be equal to a to the y. Let's express both of these as a logarithm. So we'd have log base b of z is equal to x, and log base a of z is equal to y. So now we know what x and y equals, we can sub these values into here. So we'll get log a base b is equal to log a base z over log b base z. Whoops. And now let's rearrange this in a nicer form so that we can get log base b of z is equal to log base a of z over log base a of b. And this is how you change the base. So let's have a look at our question. And let's just focus on the log base 2 of 9 bit. So let's say we wanted to change the base to 7. So here, our b is 2 and z is 9. So log base 2 of 9 is equal to log base whatever we want of 9 divided by log base of whatever we want of 2. So here we want our base to be 7, so we can write log base 2 of 9 as log base 7 of 9 over log base 7 of 2. And then here you would just sub this back into the equation and you can solve it easily from there. We already know that log base a of a is equal to 1 from the previous video. This is because if you take a to be 10, say, we know that 10 is equal to 10 to the power of 1. So we can just write this in terms of log as log base 10 of 10 is equal to 1. So here our base and number are equal, and that's why we get our right-hand side equal to 1. Next up, inverse functions. Now we talked about this very briefly in the previous video, but I want to explain this and see how this actually works together. Let's consider log base 5 of 25. So we know that this is obviously 2. So we can say that log base 5 of 25 is equal to 2, because 5 squared is equal to 25. Okay, that's great. But what if we wanted to switch the numbers around? So log base 25 of 5. Now it's a little more tricky to find this out. But this is just the same as saying, what is 5 expressed as a power of 25? In other words, 25 to the power of something gives us 5. And what is that something? That's what we're trying to work out. Okay, so we know that 5 is the square root of 25. So we can say that 5 is equal to 25 to the power half. And let's express this as a logarithm. So hopefully you should get log base 25 of 5 is equal to a half. Let's write this in. We have a half. Now, why do we consider the relationship between log base 5 of 25 and log base 25 of 5? So hopefully you can spot this pattern. We can say that log base 25 of 5 is just the same as saying 1 over log base 5 of 25. Can you see that? Because we have half is equal to 1 over log base 5 of 25, which is 2. That is obviously true. Half is equal to half. So in a more general manner, you can say that log base b of a is 1 over log base a of b. Let's summarize what we learned in these past 2 videos. So, if we have a to the x equals n, this is the same as saying log base a of n is equal to x. We know that log base a of 1 is equal to 0 for any base, and we know that log base a of a is equal to 1, because a to the power of 1 will always equal a. Now our 3 laws, so they are log base a of x times by y is the same as saying log base a of x plus log base a of y. So this is known as the multiplication law. Our next law, the division law, states that log base a of x over y is the same as log base a of x minus log base a of y. That's the division law. And our final law, the power law, says that log base a of x to the k is equal to k log a of x. That is a power law. Something I didn't mention is that from the power law, we can actually say that log base a of 1 over x is equal to minus log base a of x. Can you see where this is coming from? Because we have log base a of 1 over x, which we can say is log base a of x to the power minus 1. And from the power law, we bring that power of minus 1 in front of the logarithm. So we get minus 1 times by log a of x, which we can just say is minus log base a of x. And you can see here that the right hand side is equal. We've also learned how to change the base. So we can write that log base a of x is equal to log base b of x over log base b of a, where b is our new base. And finally, from this change of base rule, we can say that log base a of b is equal to 1 over log base b of a. So that's it for this video. Thank you so much for watching, and I hope that you found it useful. I will see you in the next video, where we'll be applying this theory together to some questions. Bye!